Hello. In this lesson, we're going to look at deriving and then applying the area formula for a circle. So the first thing that we're going to do is derive it. We're going to use kind of an informal picture proof for this. You will formally do the entire derivation for the area of a circle in your calculus class, but that is years down the road. So right now we're going to do a little informal picture proof justification for it. So here's the idea. If I want the area of the circle, imagine the circle representing a pizza. And I'm going to divide the pizza up into a bunch of very thin slices. And then I'm going to rearrange those slices into the following shape. Well, as those slices become thinner and thinner, this is going to better approximate a parallelogram. And so all I need to do is find the area of that parallelogram. And because it's made up of the same number of pieces that the circle is, it has to be the same area as the circle. Well, we know that the area of a parallelogram is base times height. So let's first talk about what the base would be. The base is the length of this. And as I cut thinner and thinner pieces, those sides right here are going to be less and less curved. They'll be more and more straight. So what is this length right here? Well, if you look and you think about it as pizza, that's the crust. But it's only half of the crusts because the other half of the crusts are on the top. So this is 1/2 of the circumference because all the way around would be all of the crusts. So this right here is half of the circumference of a circle. And then the height of it is just the length of each piece. And the length of each piece is the radius of the circle. So the base is 1/2 of the circumference. And the height of the parallelogram would be the radius of the circle. Now I need to recall what the circumference of a circle is. The circumference of a circle is 2 pi r. And so I'm going to substitute that in for my circumference. So I end up getting 1/2 times 2 pi r times r. 1/2 times 2 will make 1, so I end up getting pi times r, and that is pi r squared. And that is where the area of a circle can be understood to come from. So area of a circle is pi r squared. How did we get it? We arranged the pieces of the circle into a parallelogram and then calculated the area of that parallelogram. So the book shares with you that the area of a circle is pi r squared. We just showed where it came from. Now once we've proven where it comes from, that's when then you get to use it always and forever. So example question. Let's say a typical bag of cheese is going to cover 900 square inches of pizza. How many bags are required for the 80 18-inch diameter pizzas a parlor sells in a typical day? So here's the pizza. It's 18 inches all the way across. That's the diameter, which means that the radius is 9 inches. So the area of one circle would be pi times its radius 9 squared. So that's going to be 81 times pi. So 81 times pi, this is 254.5 inches squared. That is one pizza. If I have 80 pizzas, that's going to be 80 times 254.5 inches squared. I'll just know that I'm talking about inches squared and multiply those two. So 80 pizzas, 254.5 times 80 is going to cover 20,360 square inches. How many bags of cheese do I need? That's where I need to do a unit conversion. So 20,360 inches squared. I need to multiply by a fancy number 1. The fancy number 1 I'm going to use is this. One bag of cheese is going to cover 900 inches squared. So I need to put inches squared on bottom so those units would cancel, and that would be one bag. So I need to take my square inches and divide by 900, and then inches squared will cancel inches squared. My only unit left will be bags, so take that number, divide by 900, and I get 22.6 bags. I obviously can't buy 0.6 bags, so that would take 23 bags. Example number 1. Example number 2. An outdoor accessories company manufactures circular covers for outdoor umbrellas, so like a big patio umbrella. If the cover is 8 inches longer than the 72-inch diameter umbrella on each side, find the area of the cover in square inches. So my first suggestion would be, if you don't understand what they're describing, draw a picture, and this is what they're describing. They're saying that the main slanted part is 72 inches across, and then it has an 8-inch overhang. So it's 8 inches extra along the entire 72-inch diameter circle. Now it asks me to calculate what the area of the circle would be, the area of the entire cover. So let's look. The area of a circle, because it's a circle, is pi times the radius squared. What is the radius, though? Well, it's 72 inches from here all the way across. So from here to here would be 36 inches. If this is 36 inches, then it's 36 plus 8, or 44 inches for the diameter of the big circle. So this from here to here would be 36 plus 8, that would be 44. So my radius is going to be 44. So area would equal pi, second, times 44 squared. And then I type that in a calculator. Square it times by pi. Area would be 6,082.1 inches squared. So takeaway message from that is, if you don't understand what they're describing, draw a picture. Can give you a chance to try. I'd like you to find the diameter of a circle that has an area of 95 square centimeters. This is kind of a backward question. I'm giving you the area, asking you to find the diameter. So probably first find the radius, and then use the relationship between the radius and the diameter to find the diameter. So pause the video now, unpause once you've had a chance to try. Okay, here's what it looked like all shown out. Area equal pi r squared. Your area is 95. First divide by pi, and then take the square root of each side. You end up getting 5.5 is the radius, so that means the diameter is double that. The diameter would be 11 centimeters. Make sure you read the entire question. It said find the diameter, not just the radius. The diameter is twice of the radius. Diameter is all the way across. Radius is half of that. The second shape that we're going to be looking at today is called a sector. It's part of a circle. It's a region of a circle bounded by a central angle and its intercepted major or minor arc. Because it's bounded by a central angle, what they mean is the vertex of that sector has to be located at the center of the circle. This right here, although it is part of a circle, it is not a sector because it doesn't have a vertex at the center. That's what makes it be a sector. A sector has to have a vertex at the center. To develop the area formula for a sector, we're going to kind of self-discover it for ourselves. So imagine I tell you the whole circle right here has an area of 24. Find what the area of the following sectors would be. What would the area of this sector be if the central angle was 90 degrees? Well, you might say that 90 degrees is 1/4 the way around the circle, so it'd be 24 times 1/4. The area of this yellow shaded piece should be 6, and you would be correct. This would be 6. I wish I could go down a little further. Let's do that. What about this one? Well, this is 30 degrees, so you would say 30 degrees is what part of a circle? Well, 360 divided by 30 is going to tell you that that is that 12, right? Yep, it's 12, so that should be 1/12 of the entire circle. The entire circle is 24, so that'd be 24 times 1/12. That should be 2. Or you could have just thought, hey, this was 90 degrees and that was 6, and this is 1/3 of the 90, so that has to be 2. What about the last one? So then these were kind of nice because they evenly went into 360. What about 110 degrees? How would you do it? Well, you would probably say the entire circle is 24, and we are 110 out of the 360 degrees around the circle. So you'd say 24 is all the way around, but we are only 110 out of 360 degrees around the entire circle. So 24 times 110 divided by 360 would say the area of that is 7.3 repeating. That makes sense because 110 degrees is bigger than 90 degrees. That's why our answer has to be bigger than 6. So we just found, essentially, the area formula for a sector. The area formula is take the area of the entire circle and then multiply by the proportion that you are around, what your central angle is divided by the total of 360. So that's our formula. Our formula, we can kind of write it down, and I'll show you how the book writes it. The book, we would write it as this: the area of a sector will equal the area of the circle times your angle, the central angle, divided by 360, because that's all the way around. If you had the entire circle, you'd be 360 over 360 be 1, so it works out. That is the area formula for a sector. I'll show you how the book writes it. The book writes it as a proportion at first, and then it solves by multiplying by pi r squared, and here we go. This right here is the area of the circle, and then we multiply by our central angle divided by 360, because that's the proportion that we are all the way around it. Let's use it for the one down below. What is the area of just this shaded blue region? Well, we should probably first find the area of the entire circle, because we know the area of the sector has to equal the area of the circle multiplied by, this is 53 out of 360 degrees around. So area of the sector, I'll just call it A sub S, is the area of the circle. The area of the circle is pi times my radius of 4 squared multiplied by 53 out of 360. This will just end up being 16 pi. So area of the sector will be 16 pi. And then I'll take 16 pi and multiply by 53 and divide by 360. So 16 pi times 53 divide by 360 tells me the area of that sector is 7.4. My units are feet. Since it's an area, it's square units. So 7.4 feet squared, or square feet. One more, then I'll have you try. A jeweler makes a pair of earrings by cutting two 55-degree sectors from a silver disc. Find the area of each sector. So the first one is just what we did essentially a second ago. The area of the sector will equal the area of the circle, pi times its radius, which is 2 squared, multiplied by the angle. Each of the earrings has a 55-degree cut, so 55 out of 360. And then I just multiply. That's essentially 4 pi times 55 divided by 360. The area of the sector would be 1.92 centimeters squared. That would be the area of each of the sectors, each of the earrings. Now they're talking about weight, because this is a three-dimensional object. If the weight of the silver disc, the entire thing, is 2.3 grams, how many milligrams does the silver wedge for each earring weigh? Well, let's first find how many just grams each of the earrings weighs. So this would be the weight of the sector will equal the weight of the entire disc times the proportion that each of the sectors is, 55 out of 360. Well, we know the weight of the entire disc is 2.3, so this would be 2.3 times 55 out of 360. Because the entire thing weighs 2.3, and we are 55 of the 360 degrees of the entire thing. So 2.3 times 55 divided by 360. That is 0.351 grams, but it asked me in milligrams. So I need to convert 0.351 grams times, it turns out that 1 gram has 1,000 milligrams. Milli is the prefix for 1,000, so grams will cancel. I need to multiply by 1,000, and when I multiply by 1,000, I'll end up with 351 milligrams will be how much each of the earrings weighs. If you take a chemistry class, you'll do a lot of conversions like that. So this kind of formula works not just for areas, it works for weights as well, because it's just a proportion. What part of the entire circle are you? I'm going to ask you to try one. Find the area of the blue sector below. I'm telling you the white part has a 65-degree angle. What's the area of the blue though? So there's two ways you can kind of do this. See which one makes the most sense to you. Try it, come back and see what the answer is. So pause the video now for a minute, two. Unpause it once you've tried it, want to see how it's worked out. Okay, your answer. So here's probably the most natural way of doing it is saying if this is a 65-degree angle, then what's the blue going to be? The blue's angle would be 360 minus 65. That's going to be 295. So this would be 295 out of 360, and then I multiply by the area of the entire. Turns out to be 311.5. Another way you could do it is you could find the area of the entire circle, then find the area of the white sector and subtract them. That'd be a little bit of a longer way, but you should still get the same answer, 311.5 square inches. And that's how areas and sectors, areas for circles and sectors work. Thank you very much. Have a good one.